again class 9th CBSE. The same lesson, that is atoms and molecules. In our previous class, we are discussing about the law of chemical combination. Today we are going to discuss about the law of constant proportion, the second law which is in our course. Laws of chemical combination. We have to study about the second law of chemical combination, that is called the law of constant proportion or law of definite proportion. Law of constant proportion or law of definite proportion. What is the meaning of the word constant or definite? It means fixed. If anything is fixed, it cannot be changed by time. That is called the law, that is the constant or the definite. If the proportion of any compound is fixed, it cannot be changed by place to place or by reaction to reaction, then it is called the definite proportion. For example, water. What is the chemical name of water? That is H2O. Okay. What is the number of hydrogen atom and oxygen atom here? The number of hydrogen atom is 2 and oxygen is 1. By atom, when 2 hydrogen atom combines with 1 oxygen atom, the substance which is formed is called the water. Okay, by the atom number on the basis of atom number. But on the basis of the mass of hydrogen is 1 and mass of oxygen, now you know very well, it is 16. Mass of hydrogen is 1 and mass of oxygen is 16. I am going to write here mass of hydrogen is 1 and mass of oxygen is 16. Okay, we have to find out the ratio of mass. For proportion, we must have to take the ratio. Here, hydrogen mass number is 1, but 2 hydrogen atom is there. So, we have to multiply it with 2. And oxygen is only 1. So, we simply put the mass of the oxygen here. 2 into 1 is 2, ratio 16. So, what is the ratio of hydrogen and oxygen by mass in water molecule? The 2 part of the hydrogen combines with 16 part of the oxygen. We are able to simplify it, and it is the theory for the proportion that we have to simplify the number. If we simplify it, 2 ones are 2, 2 8s are 16. So by mass, when 1 part of the hydrogen combines with 8 part of the oxygen, then water molecule is formed. Now what about the water? This is the definite proportion. What is the definite proportion of water? The definite proportion of water is the 1:8. The fixed proportion of water is 1:8. And what about the water? Water, it may be collected from your tap, okay, from your RO or from your well, from any pond, any river, but every time the composition of water is only H2O. It is fixed. It is not changed from place to place or reaction to reaction. If water is produced as the end product of any reaction, such as the respiration, then also the formula of water is H2O. It means the proportion is always fixed. That is the second law. According to this law, the pure chemical compound is always made up of same element combined together in fixed proportion. The proportion will not change from place to place, and proportion by mass, it is always fixed. It is not changed from place to place. So this is the second law of chemical combination that we call the law of constant proportion or definite proportion. Now law. Firstly, this law was proposed by J. Proust. This law was proposed by J. Prost. Okay, this is he was the second chemist to work on this field in the law of chemical combination. So J. Prost in year 1799. In 1799, this law was proposed by J. Prost in year 1799. What this law states that during a chemical process, a pure chemical compound is always made up of is always made up of pure compound is always made up of same element which are combined together in a fixed or definite proportion by mass. So always made up of same elements which are combined together in a definite proportion a constant proportion by mass. So this is the law of constant proportion or a definite proportion. For example, one example I already taught you, water, that is H2O. The formula is fixed, that is H2O. What is the ratio of hydrogen and oxygen by mass? The ratio of hydrogen and oxygen is 1:8. Okay, it is fixed whether this water is collected from any source. It is from the river, tap, from RO water or pond water or well, tube well. What are the sources is there? The varied sources are there. But what always the formula we say, okay, water H2O from river, from pond, from well, from tube well, whatever the sources, the formula, the composition, the combination, the mass ratio never be changed. Some more example is there. One more common example is carbon dioxide. You know very well what is the carbon dioxide. There are various sources of carbon dioxide. Carbon dioxide is produced by burning fuel. Okay, burning fuel. When we burn the fuel, carbon dioxide is liberated out. Okay, if we some acidic action, it is also produced by acidic action. We also produce carbon dioxide by respiration. So there are various sources of the production of carbon dioxide. But the formula is always CO2. It never be changed. You know very well what is the mass of carbon? It is 12. What is the mass of oxygen? It is 16. If we calculate the mass ratio, the proportion of carbon and oxygen in carbon dioxide, so what we get? Carbon ratio oxygen in carbon dioxide. One part of the carbon combines with two parts of the oxygen. So it is 12:32. And how we simplify it? By dividing it by 4. 4 3s are 12 and 4 8s are 32. It means the carbon and oxygen, whether it is produced from different sources, by mass, their combination is always fixed. That is the 3:8. So this is the law called the law of the definite proportion or the constant proportion given by the Prost in 1799. And according to this law, in any chemical combination, the compound or the compound which is formed or which is taking the part in that reaction are always made up of the same element. And when they combine together, it is necessary that their proportion is always a definite. It not be changed. And that definite proportion we have to calculate from mass of the particular element. We are able to calculate that proportion. So this is the second law, that is called the law of constant proportion or law of definite proportion. Now let's solve the solution from it based on this law. Problem that's in an experiment 2.192 gram of copper oxide was obtained from 1.751 gram of copper. In another experiment, in another experiment 1.824 gram 1.824 gram of copper oxide on reduction gave 1.457 gram 1.457 gram of copper. Now show that the given data illustrate the law of constant proportion or definite proportion. Okay, now what is the question given here? There are two experiments are there. In first experiment, copper oxide was obtained from copper. The amount of copper oxide is given there. Amount of copper is also given there. What happened in the second experiment? In second experiment, again the copper oxide is formed by the reduction of particular amount of copper. There are two reactions are given there. You have to prove that this is verify the law of definite proportion or law of constant proportion. Okay, now let's move. The two conditions are there. It means that we have to calculate in two places, and then we have to calculate what is the proportion of the copper oxide in first condition and what is the proportion of copper oxide in second condition. Okay, now must solve the solution of that. Now first in experiment 1. In solution in experiment 1. In experiment 1. Now students must remember each and every question has a pattern to solve it. Do not take the zigzag method or direct method. You have to give the proper steps to solve any questions. Okay. So what happened in the first condition? In first experiment, the mass of copper is given there. Mass of copper is given there. And mass of copper oxide is also given there. Mass of copper oxide is also given there. When the copper oxide is formed, it means copper combines with oxygen to form the copper oxide. So what is the mass of copper here? See, 2.192 gram of copper oxide. So copper oxide is 2.192 gram of copper oxide obtained from 1.751 gram of oxygen. Similarly, in second experiment, in experiment 2, The masses are given there. That is the mass of copper and mass of copper oxide. Now, what is the mass of copper given in the second experiment? In another experiment, 1.824 gram of copper oxide. Copper oxide 1.824 gram. And what is the mass of the copper? Copper is 1.457. 1.457 gram. So this is the two condition given. In first condition, the composition is like this. In second condition, composition is like this. Always remember, copper converted into copper oxide only when copper combines with oxygen. Copper combines with oxygen to form carbon dioxide. Here mass of the oxygen is not given. Here also the mass of the oxygen is not given. So we have to find out the mass of the oxygen first. Now what is the mass of the oxygen? Mass of oxygen is actually mass of copper oxide minus mass of copper. Mass of copper. Okay. What is given here? The mass of copper oxide is 2.192 gram and mass of copper is 1.751 gram. So you have to subtract it. Subtract whatever the answer you get here. You have to find out. 2 minus 1 is 1. Okay. 9 minus 5 is 4. Then here only 1 is there. It borrow 1 from here. It becomes 11. 11 minus 7 is 4. Okay. Then 0.1 minus 1 is 0. So what is the value we get here? What is the amount we get here? Mass of oxygen is 0.441 gram. Now what we have to calculate? We have to calculate the percentage of copper in copper oxide and percentage of oxygen in copper oxide. Must calculate the percentage of copper in copper oxide. Okay, how we calculate the percentage? For percentage, we have to multiply the value with the 100. We have to take the mass of the copper divided by the mass of the copper oxide and then we have to multiply it with the 100. Okay, mass of the copper. We have to find out the copper. So, mass of the copper is 1.751 divided by mass of the copper oxide. This is 2.192 and then multiply it with the 100. Okay, what we get here, you have to find it out. What amount you get here, you have to solve it and you have to calculate the value. The value, it may be 79.9. Okay, it is equal to 79.9. We must solve the second condition. Letter word. I am going to rub this. In second condition, we must calculate it after the calculation of the first one. Then we calculate the second one. So, we must move further here. Okay. This is the mass of the copper in copper oxide. Now, we have to calculate the percentage of oxygen in copper oxide. Again, what we have to take in? We have to take in mass of the oxygen, that is 0.441. 0.441 divided by mass of the copper oxide, it is 2.192. 2.192 into 100 because we have to calculate the percentage, and if we have to calculate the percentage, whatever we have to do, we have to multiply it with the that is 100. Now let's calculate it. What amount you get here? Calculate and find out what amount you get here. It might be 20.1%. Okay, so what is the percentage of copper? It is 79.9. What is the percentage of oxygen? That is the 20.1. Okay, what is the total percent? If we want to calculate, 9 plus 1, 10, 0. 79 plus 20 is 99 plus 100. Total percentage of the substance is the 100 only. It means it has a definite proportion. So this is the proportion by mass in the first condition. Now we have to calculate the proportion in the second condition also. So same question in experiment 2. Again, the mass of copper is given there. Mass of copper and mass of copper oxide. Mass of copper oxide. Okay, now what is given here? In another experiment, 1.824. 1.824 gram of copper oxide on reduction gave 1.457. 1.457 gram of copper. Okay, you have to verify the law of constant proportion. We have to calculate again the mass of oxygen. The mass of oxygen is actually the mass of copper oxide minus mass of copper. It is 1.824 minus 1.457. Now subtract it. Okay. Now subtract it. Okay. 14 minus 7 is 7. Then here 11 minus 5 is 6. And here 7 minus 4. 7 minus 4 is 3. So what we get here? We get here 367. This is the mass of oxygen in gram. Now what we have to find out? We have to find the percentage. Now percentage of copper in copper oxide. This we are doing for the second experiment. Now what is the mass of the copper? 1.457 divided by the mass of the copper oxide, that is 1.824 into 100. Solve it. You get the same answer, that is 79.9%. Then find out the percentage of oxygen in copper oxide. The mass of oxygen is 0.367 divided by mass of copper oxide, that is 1.824 into 100. Again you get the same answer, that is the 20.1%. So there are two different sources from where we get the copper oxide. In one condition it is by the simple reaction, and in one condition it is by reduction. But the ratio becomes the same, that is 79.9 ratio 20.1. 79.9 ratio 20.1. It means this verify the law of constant proportion. What is the conclusion? This verify because the mass of copper and oxygen is same in both the conditions, both the experiment. So it verifies the law of constant proportion. Okay students, it is quite easy. If the question is given in the exam, what is law of constant proportion, what is the law of conservation of mass, but hardly these questions are asked in the examination. Always the same type of the questions, like this type of the questions are given in the exam. So practice well.